All right, today we've got section 8.1. Our objective is to solve equations in two variables over given domains of the variables. That'll make more sense when we start doing example problems, but basically that means that our equations will have both an x and a y, and we are going to be figuring out which pairs of x and y work for those equations. To warm up, we have to evaluate some expressions for a given value of x. So x is equal to 12. We need to evaluate 5x minus 2. Notice that this does not have an equal sign. This is just an expression, not an equation. So to evaluate, we substitute, then simplify. It's been a while since we've done this. Substitute, then simplify. So we substitute 12 in for the x. Then we have to simplify it. What operation comes first, Keon? Well, okay, good. So parentheses, but there's nothing to do inside the parentheses. So we go to multiplication. 5 times 12 is 60. 60 minus 2 is 58. On number 2, it's the same kind of thing. We're going to substitute, then simplify. So we take 2/3 times 12 plus 7. Multiplication still comes before addition. So we have to take 2/3 times 12. Can anyone raise their hand and tell me what that should be? Carl, you want to try raising your hand? All right, what do you think it is? 8. We take 2 times 12, that's 24, divided by 3 is 8. And 8 plus 7 is 15. So that is a skill we will need today. We are going to be substituting in values and simplifying. All right, we've got a note, just a reminder. The solutions to equations with one variable are just numbers. For example, 10x plus 12 equals 22. Who can raise their hand and tell me how we would start solving that? Got to see new hands, or we're just going to start pulling sticks. Jaquan? First, we would subtract 12 from both sides. That leaves me with 10x equals 10. Ellie, what would I do next? Divide both sides by 10. I get that x equals 1. So that is my solution. So the solution to equations with one variable are just numbers. So the only variable we had in that equation was x. Our answer was a single number. The solutions to equations with two variables are ordered pairs. So that's what we'll be seeing today. Ordered pairs, which, if you need a reminder, ordered pairs are x, comma, y in parentheses. It looks like a point that you would plot on a coordinate plane. All right, this set of examples, we are just stating whether or not the ordered pair that they give us is a solution to this equation. So remember, our ordered pairs are x, comma, y. So that means x, comma, y. So when I go to check this, I'm going to substitute 2 into x and 7 into y. So I'm going to rewrite this and substitute into both x and y and see if it comes out to be true or not. See if it works. So 7 times 2 minus 2 times 7 equals 0. Sometimes you might see people put a little question mark above it, above the equal sign, because that's what we're checking to see. Are those two sides going to be equal? If you don't put the little question mark, it's not the end of the world, but we still evaluate it the same way. What is 7 times 2? What is 2 times 7? What's 14 minus 14? So did this work? Yes. Okay, if you end up with the number you were supposed to, or a true statement, then yes, it is a solution.
So you want to write yes?
Your answer to that would be yes. Or you could write is a solution. Yes, it is a solution. That one works. So again, over here we've got x comma y. So we're going to try again here. We've got 7 times 3 minus 2 times 4 equals 0. Again, we're wondering if that's true. What's 7 times 3? 21. Minus 2 times 4? I should hear more people answering these. These are basic facts. What's 2 times 4? 8. What's 21 minus 8? 13. Does 13 equal 0? No, 13 does not equal 0. So do we think this is a solution? No. It is not a solution. Once you've had a couple minutes to try this one out, we can compare with a partner next to us, and then we will put the solutions up on the board. All right, we're going to do a thumbs up, thumbs down. Who got yes for A? Thumbs up if you got yes, thumbs down if you got no. Most people got a thumbs up. So most of us think that this one's a yes. Sorry, I didn't mean to do that. Okay, so most people think this is a yes. What about B? Thumbs up for yes, thumbs down for no. Seeing mostly thumbs down, so most people think this one's a no. Let's check and see. So on this first one, well, on both of them, we're using this equation that they gave us. We are plugging in our x and y from these ordered pairs that they gave us. So I rewrite this whole equation, but instead of putting an x, what am I going to put? A 4. Instead of a y, what am I putting? A -2. So we have 4 times 4 plus 3 times -2. We're wondering if that will come out to equal 10. 4 times 4? 16 plus 3 times -2. -6 equals 10. What is 16 plus -6? 10. Does 10 equal 10? Yes. So good. We got that one right. All right, on part B. 4 times 3 plus 3 times -1. It's still x comma y. We're wondering if that will come out to equal 10. 4 times 3? 12. 3 times -1? -3. What's 12 plus -3? 9. Does 9 equal 10? No. So this one is no, it's not a solution. All right, our next set of examples is actually pretty similar. However, we've got a special note here. If other variables besides x and y are used, they are in alphabetical order. So for these ordered pairs, we would say that this is A, comma, B. A, comma, B. So if they use something other than x and y, we always assume it's in alphabetical order. These ones have fractions in them, but they're still not any different. We're going to take this equation that they give us and plug in the values they ask us to. So what am I plugging in for A? Negative 1/2 minus 3 times, what's going in for B? Negative 5 equals 16. All right, 2 times negative 1/2. Positive or negative? Negative. A positive times a negative comes out to be negative. Negative 1. A negative 3 times a negative 5 is a positive 15. Negative 1 plus 15. 14. Very good. Watch your signs so you know what you're doing. Are those equal? No, they are not. So no, this one is not a solution. You have to be careful with your signs on that one. If you're not careful and you put this as a positive 1, you would think that it would come out to be a solution. Make sure you're watching your signs. All right, on part B, what am I plugging in for A? Negative 5/2 minus 3 times, what's going in for B? Negative 7. We're wondering if that will come out to equal 16. All right, if we've got 2 times negative 5/2, what do we get? Negative 5. Good. That 2 in the denominator, they just cancel each other out. Negative 3 times negative 7. A negative times a negative is a positive 21. What's negative 5 plus 21? 16. Is this one a solution? Yes, it is. Make sure you're showing all the same work that I'm showing. I need to see a step where you plug in your X and Y or your A and B, whatever your variables are. I got to see a step where you plug it in. And then I need to see your step simplifying it. I need to see this last step where it's a number equal to a number, where you decide whether or not it's right or not. Do not stop at this line above. Even if you can tell what it is from there, I want to see all the work. All right, example 4. Again, it's the same type of problem. It just looks a little different. Who can raise their hand and tell me what looks different about this problem? Deja? We have exponents. We've got x squared and y squared. Who can raise their hand and tell me what it means to square something? Jakeem? So it involves multiplication. So what should I think of when I see 5 squared, Jakeem? 5 times 5. So you multiply that number by itself. Alright, so let's keep that in mind while we do these. Again, it's the same thing. We've got x comma y. We're going to substitute them in and evaluate, see if it comes out to be true or not. So I have 5 squared plus 3 times 0 squared equals 75. Now with squareds, we have to be careful. It's easy on the x squared because there's not anything out in front of it, so it's just 5 squared. 5 times 5 is 25. On the next one, the 3 times y squared. Remember, we do parentheses, then exponents, then multiplication and division. And this exponent only belongs to the y. So what is 0 squared? 0 times 3, still 0. What's 25 plus 0? Does 25 equal 75? No, so this one is not a solution. All right, on part B. What am I plugging in for x? 0 squared plus 3 times what's going in for y? 5 squared equals 75. 0 squared plus 3 times what's 5 squared? 25 equals 75. What's 3 times 25? Plus 0. Still just 75. Does this one work? Yes, it does. On this one, if we had multiplied the 3 and the 5 before we used the exponent, we would have thought that it doesn't work. We would have had 15 squared, which is 225, and that wouldn't have worked out. So make sure you're being careful with exponents. Lots of things to be careful with. Signs, exponents, what gets plugged in where. Questions before we go on? This 25? 5 squared. 5 times 5 is 25. Anything else? Okay. All right, note, many times equations with 2 variables should have y by itself. This is not always a requirement, but it will usually make our lives easier, especially when we start moving into graphing. Alright, so we are aiming to get y by itself. We haven't really done a whole lot like this before. We're trying to solve for a variable, but we have another variable still in there. If I'm trying to get y by itself, what needs to move from the left side of this equation? The x term. We're trying to get y to stay put and be alone. So we're going to want to move the 2x. Right now, the 2x is positive. How am I going to make it 0 out? So dividing by 2 is not going to make it 0 out completely. Subtract. But we don't just subtract 2, we want the whole thing to 0 out so that y can be all alone. So we subtract 2x. But if I do that to one side of an equation, where else does it have to happen? The other side of the equation. So I subtract 2x on that side. Okay, so we wanted to 0 out the x term. So we subtracted it on both sides. That'll make it 0 out on the left, so that all we're left with is a positive 1y. That's what we wanted. Lexi brought up the point that we cannot combine these. The 4 does not have an x. So what that means for us is that we are just going to have to leave it as 4 minus 2x. Or, how you'll see it written more often is negative 2x plus 4. So we keep the sign of the number with it. So this 4 was positive, that's why I wrote a plus 4. Either one of these is technically okay. When we move forward in this chapter, you're going to need to be able to write it like the bottom way, with the x coming first. But for today, if you just get it to this top part, it would be okay. But like Lexi said, you cannot combine those, so don't do it. On example 6, we are trying to get y by itself. So we're going to leave the y alone. Don't move the y around. Move everything else. What's the first thing I should get rid of? We want to get rid of that x term. Right now it's a positive 3x, so to make it 0 out, I subtract 3x. But if I do it to one side, I have to do it to the other. When I do that, what sign is still in front of the y? a minus sign or a negative sign, however you want to view it. So this is negative y is equal to 7 minus 3x. Again, these don't get combined. The 7 doesn't have an x. But I don't want a negative y, I want a positive y. So if I change the sign on my y, make sure you're paying attention to this step. The other signs will change on the other side, both of them. So instead of a positive 7, it will be negative 7. Instead of minus 3x, it will be plus 3x. Okay, so this would be one option. Or we would have y equals, the 3x is positive, the 7 is negative. So either one of those works for a final answer. The important part on that one is that when we switch the y from being negative to being positive, we switch all of the signs on the other side. So we switch the sign on the 7 and on the 3x. If you only switch one of them, it's not going to work. We are still trying to get y all by itself. Our first step isn't going to be much different from what we were doing before. What do you think we should do? Subtract the 2x. We got to get that over. If we do it to one side, do it to the other side. That leaves us with 5y equals 9 minus 2x. All right. How am I going to get y all alone? Divide by 5. But if I do it to one side, got to do it to the other. So we divide the whole other side by 5. So that leaves us with y equals 9 minus 2x over 5. Or we still can write it as a negative 2x plus 9, all divided by 5. Or you can split your denominator up, so it would be y equals 9/5 minus 2x over 5, or y equals negative 2x over 5 plus 9/5. We've got lots and lots of options of how we will write these. So any 4 of these would be appropriate. The way that we will see most often going forward in this chapter is going to be this last way. That'll be our most popular way of looking at it. But any of them would work. So if you just do the basic right here, that first one we got, that's totally fine with me for today. So our steps for finding solutions to an equation, I should say with 2 variables, would first be to get y by itself. Next, we substitute values for x to find values of y. Then we write the solutions as ordered pairs. All right, we're going to follow those steps. The first step was to get y by itself. Who can raise their hand and tell me how to do that? Natalie. Subtract x from both sides. So y equals 3 minus x, or you could put negative x plus 3. On this table, usually I think you're going to be told what values of x to use to begin with. Eventually, you're going to have to pick values of x when we do table problems like this. But for today, I'll tell you that on this problem, I want you to use negative 1 0, 1, and 2. So this box in the middle here says y equals. We got that y equals 3 minus x. So when we go down this table, we're going to plug in our x value. So here, this is going to be y equals 3 minus negative 1. You don't have to put the y equals on this part. 3 minus 0. 3 minus 1. 3 minus 2. And then finally, we have to fill in our y column, which is what we get when we evaluate these. All right, so we start evaluating our middle column. What is 3 minus negative 1, Ellie? 4. 3 minus 0, everyone. That was not everyone. That was a few more people. 3. 3 minus 1, everyone. 2. And 3 minus 2, 1. Okay, so for the examples that we chose, these are not all inclusive, but for the ones that we did, we have to write our solutions as ordered pairs, meaning x comma y. If I plugged in 4 different x's, that means I've got 4 different ordered pairs that I should be writing. Who can raise their hand and tell me what they think one ordered pair should be? Tariana. Very good. X, comma, y, negative 1, 4 is one solution. Somebody new, raise their hand to tell me another one. Lexi. 0, comma, 3. Somebody else that I haven't heard from yet today? Ryan? 1, comma, 2. One more new volunteer. Danielle? 2, comma, 1. Wonderful. This does not mean that these are the only possible solutions, but based on the ones we picked for x, these are the solutions we ended up with. All right, I want you to try this example on your own, so that means get y by itself, plug in values for x, figure out what your y's will be, and write them as ordered pairs. On this one, I want to use -3, -1, 0, and 5 for my x's. So I'll give you a couple minutes to work on that, possibly discuss with a partner, and then we'll go over them. All right, who wants to tell me what they got for our equation when y is by itself? Someone I have not heard from yet today, or I'll just pull sticks. Stick it will be. Well, Ellie, do you want to help us out? What did you get when you got y by itself?
I got y equals -2 minus 3x.
Wonderful. -2 minus 3x. You could write it as -3x minus 2. Either way is fine. We got that by subtracting 3x from both sides. So -2 minus 3x is the expression we're working with. So then for this middle column, all you're doing is plugging in your x value. So we're just taking the x value that we have in our first column here and plugging it into that x. And then our last column is what we get when we evaluate those. So what do we get for y when x is -3? Houston's not here. Jamal Dixon. What did you get for y when x was -3? A -7? I think it should be a +7. negative 3 times negative 3 is positive 9. So negative 2 plus 9 would be 7. Negative 2 plus 9. That's how we got that 7. So if you need to, you can show more steps in there. This would be negative 2 plus 3. So when x was negative 1, May, what did you get? 1 for y. We can do the same thing here. Negative 2 plus. That would end up giving us a 0. Tariana, what did you get? We took negative 2 plus 0. Yep. Negative 2. And on that last one, Jeriel, what did you get? Negative 2 minus 15. Because the 5 is positive. They're both negative, so we add and keep it negative. Both of the numbers are negative, so we add the numbers and keep it negative. Negative 17. The last part of this is that we have to write these as ordered pairs. Do I have any new volunteers to help me out with my ordered pairs? None of these volunteers are new. Delaney.
Negative 3 and 7.
Negative 3 comma 7 is one of them. Danielle, do you want to give us another one? Negative 1, 1. Keon, what's another? 0, negative 2. And my last one, Delaney again.
5 and then negative 17.
5, negative 17.